the inverse of a function reverses that function. Take out another. That should be that. The inverse of a function reverses it. And the special notation that we use is a -1 exponent. So you might see it as y with a -1, or we've been talking about function notation. You might see it like this, f inverse of x. But a -1 exponent tells us we're looking at an inverse. And basically, when you have two functions that are inverses of each other, let's say the original function has the point 34. If we just look at the graph of it, it might have the point 34 on it, and if it does, that means its inverse would have the point 43. All of the x's and y's are flipped from one function to its inverse. So, when we're going to find the inverse of a function, we're going to start by flipping or switching the x and the y. And then we're going to rearrange. We're going to take the steps like you all did on your boards, and we're going to solve that to get the y back by itself. And that will give us its inverse. Okay? So, number one, this is my original function, and I'm asking you to find its inverse. So rewrite this, but switch the x and the y. So it's going to become x equals 3y plus 5. And we're going to treat this like it's a two-step equation. I gave you an example just like this on your boards that you all practice, except it had a number there. That's what you're used to. What we're going to do is treat it the same kind of steps like it's a number, but our answer will have an x left in it. So if this was your problem, what normal first step would you take? Subtract 5. So that's what we're going to do. We're going to subtract 5 from both sides. Those cancel. A positive 5 and a minus 5, we do that to make them cancel. That makes 0. 5 and minus 5. Yeah. I thought you said how. Alright, so x minus 5. You can't type that in your calculator. If you do, if everybody in here typed in x minus 5 and hit enter, most of you would get different answers. Because your calculator thinks that x is some number. We're not treating it like a number. All we're going to do is just write down x minus 5 equals 3y. Your calculator wouldn't give you x minus 5. It might give you something totally random. 27, 300, negative 5.
47.
Yeah. Okay. Alright, so we have x minus 5 equals 3y. If my goal is to get y by itself, how would I get rid of this 3?
Divide.
Yep, so we're going to divide
By x.
Both sides by 3. You divide by the number that's with your y. And now is my y by itself? Yes. So my answer is x minus 5 over 3. And I'm going to say that's equal to y inverse. Y with the -1 exponent.
It doesn't make any sense. Do you have to put the negative ones?
I mean, I'm not going to count it wrong.
I got a question.
See, look, it's totally still
What was the point in changing them in the beginning?
Well, because their functions, the x's and y's are changed. These are two different equations, but they're inverses of each other. When we have functions, I don't want to leave it like this because you never see anything as x equals. In your graph, in your calculator, when you go to graph, it needs to be y equals. So that's why we had to move it around to make it y equals. Okay. Alright, so number 2. My original function is y equals 7 plus 2x. I want you to find the inverse. You're going to do that by switching the x and the y. Because in inverses, functions that have inverses, their x's and y's are switched. So x equals 7 plus 2y. But that's not going to work because we need it to be y equals. So what step would I take first to get the y by itself? Yep, this 7, anytime you got a number that's by itself, we're going to subtract that number. So minus 7. So that causes those to cancel. On the left side, what do I write down? Just x minus 7 equals, and then I bring down that 2y. I haven't done anything with that yet. Is the y by itself? Nope, there's a 2 with it. How do you get rid of that 2? Divide both sides by 2. Does that get my y by itself? Sure does. So x minus 7 over 2 equals y, but I'm going to put the negative 1 to show that this was the inverse that I found.
We always put the negative 1.
Yeah. If you're finding the inverse. Any questions so far on how I did those? If you did not know how to solve a two-step equation to begin with, this is probably doesn't make sense. If you did, it's the same steps. Alright, number 3, I gave you one like this on your boards that you worked on. Y equals 3x squared. So we first want to switch the x and the y. That's how we find the inverse. Okay. And my goal is to get the y by itself. Now we can't get rid of the square just yet. We've got to get rid of the 3 first. How do I get rid of that 3? Divide by 3. Yep. And so I just have x over 3 equals y squared. Is my y by itself?
Yes. No. Well, no, it's squared.
No,
right
it
now.
has a squared. How do you get rid of an exponent of 2? No.
Oh, square root.
Square root. So I take the square root of both sides. And basically, over here, a square root and an exponent of 2 cancel each other out. So I can cross those out. Just like I crossed out the 3's. And this 5 and the minus 5. We cross them out.
They don't exist anymore.
So on the left, I've got the square root of x over 3. And that was equal to y. I'm going to put my negative 1 exponent to show that that's the inverse.
Easy as.
If I gave you the answer that I'm boxing in, if I gave you that problem and told you to find the inverse of it, you would get the original question. It works both ways that you go. Alright, number 4. We have y equals the square root of x minus 3. So start out by switching your x and your y. Inverses, x's and y's are switched. X equals the square root of y minus 3. Similar to the last type of problem I gave you on the board. Now, with square roots, if there was anything outside of the square root, like anything in the front or like added or subtracted at the end, we would have to get rid of that first. Do I have anything outside of the square root? No. So we can get rid of the square root first. I can't add 3 yet to both sides because right now that minus 3 is housed inside of the square root symbol. You can't just pull it out. It's like trying to yank somebody through a wall. Doesn't work. So how do I get rid of a square root symbol? How did we do that on the boards?
What do you think, Bert?
What did we do here? We gave it an exponent of 2. A square root and an exponent of 2 are opposites. A cubed root and an exponent of 3 are opposite. A fourth root and an exponent of 4 are opposites. Yep. So I'm going to square both sides.
I get excited.
Okay. So I took both sides and raised them to the second power. On the left, that's just x squared. Again, you can't type that in the calculator. It'll give you some random number because your calculator thinks that x stands for something.
So square root.
Okay, so it's just x squared equals. Now on this side, an exponent of 2 and a square root symbol cancel each other out. So I'm just left with y minus 3. Is y by itself? Nope. How am I going to get y by itself?
Add 3.
Add 3 to both sides. So those cancel. X squared plus 3 equals y, and I should have done that in my purple because that was it. Plus 3. Number 5, y equals the square root of x plus 9. This one also has a square root like number 4, but what's different about it?
It's only over n.
Right, only the x is under the square root. That plus 9 is on the outside. So yesterday we talked about translations. This would be a square root function that went up 9, right? The last one, number 4, would be a square root function that went right 3. We learned that yesterday. So if you have something added or subtracted or whatever outside, we need to get rid of that first. So let's rewrite it. X equals the square root of y. Make sure when you're writing neat enough that you can tell that that plus 9 is on the outside.
Right.
Don't get so sloppy and go so fast that it looks like your plus 9 is under the bar. So we have x equals the square root of y plus 9. And we got to get rid of the 9 first because it's outside. How do I get rid of that plus 9? Subtract 9. X minus 9 equals the square root of y.
One's by itself.
I think the y is by itself. What's stuck with the y?
We got a 2.
Well, Luke,
A square root's with it, so we have to do what? An exponent of 2. So we do this side with an exponent of 2. That just cancels the square root symbol and stuff out. And then we do this side to an exponent of 2. And you're just going to leave it like that. X minus 9 in parentheses squared equals y. Alright, number 6. Go ahead and rewrite it, but switch your X and Y. Y. That's always the first step in finding the inverse. Because in a function and its inverse, the x's and y's are flipped. Like I showed you this example up here.
Wait, never mind.
The x's and y's are flipped.
I thought you meant like switch it up. Turn those two around.
Okay. Alright, now, what do you think? If we just pretend that 4 is not there, what step would you do first? Subtract 1. Those cancel. I have x minus 1 equals 2y to the 4th. All right. If that 4 wasn't there, what would my next step be? Divide by 2. Running out of room. Okay. So I have x minus 1 over 2 equals y to the 4th. Now, and we had an exponent of 2, we took the square root. This one has an exponent of 4, so I'm going to take the 4th root. And all that is, it looks like the square root symbol, but right here in the little corner, you draw a little 4. So just right there, the beginning of your symbol, that means the 4th root.
And then are you just gonna write
And
it
so,
down like that?
Yep. So now, like my 4th root and my 4 exponent cancel, and my answer is the 4th root of x minus 1 over 2. So that one was tough.
These. Same thing, different day.
Alright, I want you to get out a scrap sheet of paper